Hi everyone, today we will discuss about aerosols. A small introduction about aerosols. The aerosol container is referred to as a pressurized package in which the therapeutically active drug is dissolved or suspended in compressed or liquid gases. The delivery of therapeutically active drug in the form of spray or foam or solid stream is dependent on the ability of the liquefied or compressed gas. The advantages of aerosols are as follows. The drug sensitivity to the effect of oxygen or moisture is protected and stability is enhanced. The drug can be directly applied to the affected areas. Administration of a drug by aerosol is a rapid process. It protects the drug from gastrointestinal tract degradation. Hepatic first pass metabolism is avoided. Aerosols are used for both systemic and local application, and it is easy to apply. A sterile dose of a drug is dispensed and also the contamination of drug is prevented. The delivery of contents of aerosols depends on its valve assembly, containers and activators as well as on the propellant. The two components of aerosols are product concentrate and propellant. The product concentrate contains the therapeutically active ingredients. The propellant have vapor pressure greater than atmospheric pressure at 40 degrees centigrade. Is responsible for the development of proper pressure in the container to expel the product concentrate in the desired form like spray, mist, solid, foam, stream, etc. Propellant can also act as a solvent or vehicle for the product concentrate. The aerosols components are also classified different types. The main definition is aerosol is a pressurized dosage forms containing one or more therapeutic active ingredients which upon activation emit a fine dispersion of liquid and or solid materials in a gaseous medium. These aerosols have some advantages and disadvantages. First of all, we will discuss about advantages. So it is easily withdrawn of drug. So it is easy and convenient to apply. So faster onset of action. So no manual or direct contact with the medicament. So avoid the first pass metabolism. A specific amount of dose or drug can be removed. No microorganism can enter. Release the contents in controlled and uniformly. Protect the photosensitive medicaments and oxygen sensitive material. Provides efficacy of a drug. Irritation can be reduced. So these are the advantages. Next we will see disadvantages. So it is costly and it is difficult disposal of empty aerosols containers and allergic in some cases. So sometimes it is explosive. Some formulations is difficult to prepare. Sometimes propellants may cause toxic reactions. So these are the disadvantages for aerosols. We have some desired characteristics. First one is less explosive, uniform and constant dose delivery, non-allergic, it is economic or low cost, so easy to handle, non-breakable and eco-friendly. So these are the desired characteristics. We have some important components to prepare aerosols that are propellant, second one is container, third one is valve and activator, and finally product concentrate. These are the components of aerosols. Next, first one we will discuss about propellants. The propellant is generally recorded as the heart of the aerosol package. It is responsible for development of pressure within the container, supplying the necessary force to expel the product when the valve is opened. The propellant also acts as a solvent and as a diluent and has much to do with determining the characteristics of the product as it leaves the container. We have two different types of propellants. First one is liquefied gaseous propellant and second one is compressed gaseous propellants. First one is liquefied gas propellants. These liquefied propellants are gases that exist as liquids under pressure. Because the aerosol is under pressure, propellants exists mainly as a liquid, but it will also be in the head space as a gas. The product is used up as the valve is opened. Some of the liquid propellant turns to gas and keeps the head space full of gas. In this way, the pressure is the can remains essentially constant and the spray performance is maintained throughout the life of the aerosols. We are using different types of liquefied gas propellants that are chlorofluorocarbons and it is also called as CFC, and some are hydrocarbons and some are hydrofluorocarbons and hydrochlorofluorocarbons. Now we will discuss chlorofluorocarbons. This propellant of choice for oral and inhalation. So advantages are chemical inertness, lack of toxicity, non-flammability, and lack of explosiveness. We have two disadvantages that are it is high cost and it depletes the ozone layer. Examples are trichloromonofluoromethane and difluoromethane. Dichlorotetrafluoromethanes are examples for chlorofluorocarbons. Next propellant is hydrocarbons. It can be used for water-based aerosols and topical use. So advantages are inexpensive and excellent solvents. It does not cause ozone depletion. And disadvantages are it is inflammable and unknown toxicity produced. Hydrocarbons examples are propane, isobutane, and butane. Next propellant are hydrofluorocarbons and hydrochlorofluorocarbons. These compounds break down in the atmosphere at faster than CFS. CFSs means chlorofluorocarbons. Lower ozone destroying effect. Here also we have advantages and disadvantages. Advantages are low inhalation toxicity, high chemical stability, high purity, not ozone depleting. So coming for disadvantages, it is poor solvent and it is also high cost. So examples are heptafluoropropane, tetrafluoroethane, difluoroethane, chlorodifluoromethane, chlorodifluoroethane. These are the examples of hydrofluorocarbons and hydrochlorofluorocarbons. Next is compressed gas propellants. Compressed gas propellants occupy the head space above the liquid in the can. When the aerosol valve is opened, the gas is pushes the liquid out of the can. The amount of gas in the head space remains the same, but it has more space, and as a result, the pressure will drop during the life of the can. Spray performance is maintained, however, by careful choice of the aerosol valve and actuator. Next, we coming to containers. They must be able to withstand pressures at a high as 140 to 180 psig. Psig is nothing but pounds per square inch gauge at 130 degree Fahrenheit. Aerosols containers we have two different types. One is metal type and second one is glass type. In metal types we have three different types. One is tin plated steel, second one is aluminum, and third one is stainless steel. Coming to glass aerosol containers, in this we have two types. One is uncoated glass and second one is plastic coated glass. Now we will discuss in metals. First one is tin plated steel. It consists of a sheet of steel plate. This sheet is coated with tin by electrolytic process. The coated sheet is cut into three pieces. One is top, bottom and body. The top bottom are attached to body by soldering. When required, it is coated with organic material, usually like oleoresin and phenolic and vinyl or epoxy coating. Welding eliminates soldering process, saves considerable manufacturing time and decreases the product or container interaction. Recent developments in welding includes soundronic system and cono-weld system. Next container is aluminum containers. It is used for inhalation and topical aerosols manufactured by impact extrusion process, light in weight, less fragile, less incompatibility due to its seamless nature, greater resistance to corrosion. Pure water and pure ethanol cause corrosion to A1 containers. Added resistance can be obtained by coating inside of the container with organic coating like phenolic, vinyl or epoxy and polymate resins. Next containers are stainless steel containers. It is commonly used for inhalation aerosols. So advantages are extremely strong and resistant to many materials and no need for internal coating. So previously two containers need coating. For this stainless steel containers no need for coating. So disadvantages are it is almost costly compared to previous two containers. Next, second type of containers is glass containers. These containers are preferred because of its aesthetic value and absence of incompatibilities. These containers are limited to the products having a lower pressure 33 psi and lower percentage of the propellant. Used for topical and MDA aerosols, two types of glass aerosols containers are available. First one is uncoated glass containers. These are less cost and high clarity and contents can be viewed at all times. Second type of glass containers are plastic coated glass containers. These are protected by plastic coating that prevents the glass from shattering in the event of breakage. Here I will attach one video. This video we can understand how to work aerosols paint spray basic principle. So here we go. In next class, we will discuss about general formulation of aerosols, manufacturing and packaging methods, and pharmaceutical applications, and finally, quality control tests for aerosols. Thank you.